So let's focus on the what reaction of what alkanol. And alkanol undergo four main type of reaction. One, conversion of alkanol into alkyl. So reaction you can convert alkanol into what alkyl using any of these what two reagents, which I will talk about. Using any of these two reagents, HCl gas in what cold ether, or you can use PbO3, phosphorus tribromine, or phosphorus trichloride in ether. Now, these ether are organic what solvent. Do you get? Now, the main reason why organic compound needs reagents, now they need catalyst or heat or any other condition for them to occur. Now, because organic reactions are very slow. At times, they can take days for the reaction to occur. So that is why every organic reaction have their own reagents or catalysts or conditions they undergo. So for you to convert alkanol into alkyl, you need what these three what reagents. Here we have toining chloride, SOCl2, toining what chloride. So the first one, this is what you need. Number two, conversion of alkanol into what alkene. Now I'm going to talk about this one here. You need H2SO4 slash what THF, tertiary furan. Now as what as the catalyst. Now this tertiary furan is the organic what solvent. You get. Now what make you guys to occur is this constituted what acid, or you can use phosphorus chloride. To get phosphorus chloride, you can use any of this one here for the. You can use any of these two for the reaction. Then we have what called oxidation of the alkanol and esterification. So let me go ahead and explain to you. So let me come first one here. Conversion of alkanol into what alkyl. So this is called substitution what reaction or displacement what reaction. If for example you have an alcohol, this one is an alcohol, and you react it with any of this reagent, can either be HCl in what ether, or you have ReOH, you have what PbO3 in ether. Now remember it can also be PCl3, right? Then we have ROH. You can use what SOCl2 slash what pyridine. So these are what various conditions, and they give similar what results. They will what give similar results. In the sense that one of the chlorine will replace this guy here. So the main product is what LCl. That is what is the main what product called alkyl what chloride. It's okay, alkyl what chloride. Now the same here, this BRO what replace OH here. Then we have what RO here, BRO. Do you see that? Alkyl what bromide. Alkyl bromide. You see that? Then this one here, Cl will replace this one, that one here. Cl, alkyl chloride. You see that? Now, these are the words. These are what the main product. Do you get? So this is how you can convert. This is how you can convert alkanol to what alkyl what halide. So let's take a good example. So if you have something like this, CH3, CH2, CH2OH. Now, when you react what one propanol, if you react what one propanol with any of these oxidized, is any of these what reagent, maybe you use your SOCl2 like pyridine. It's okay. What's going to happen here? Now, the answer is very easy here. You're going to produce, now this one, you want to remove one here and replace what with Cl. This is that chlorine. So it will be CH3, CH2, CH2, then what Cl. Cl. So the answer is going to be 1 chloropropane. This is that 1 chloropropane. Another thing you must understand that for every product you give, you must produce the name of that product. It's very important. That is why you need to understand or master what nomenclature of the organic compound. So, if for example here I have something like this, then What will be the product when HCl, so what enter, react with it? It's very easy here. Now, this will also remove this one here as from the ring to produce. This is that. So going to be chloro chlorocyclohexane. Chlorocyclohexane. That is the what name of what of the product. So that is how what you can convert what alkanol into what any of the alkyl halide, depending on what on the alkyl halide. So depending on what on the alcohol, they're going to do the alkyl halide that we're going to what produce. So let me to the next one. Conversion of alkanol into alkenes. So conversion of alkanol into what alkene. Now another name of this reaction is called dehydration reaction. Dehydration reaction. When we talk about dehydration reaction, that is a removing of water, a water molecule. If for example you have CH3, CH2, CH2OH. It's okay. Now this guy name is what? One propanol. This is that. Now when it reacts with any of these reagents here, H2SO4/THF. It's okay. Now you have to remove a molecule of water. In the sense that now OH from this first carbon here and hydrogen from this second carbon here will go out. Now when we talk about dehydration reaction, there is you are removing of you are remove water from the alkanol to form alkenes. This is that. So what will happen here? OH here will go. Remember, here we have two hydrogen. Here we have two hydrogen. Here we have OH. So OH from here and one of the hydrogen from here will go out. Just that will go out to form water. So if that is done, I can write this one as what as hydrogen. This that. So these two go out as what as H2O. Now when you remove these two things here, do what I'm going to get CH3, CH CH2. You're now going to form a double bond plus what? H2O. This is that. So instead that when you remove what OH from one carbon and hydrogen from another carbon here, a double bond will be formed between two of them. That is what we call the hydration or reaction. And then now as what? Propene. Going forward, propene. Propene because it has what a double bond. That is what name of what of the compound. So if I have something like this, CH3, CH2, CH2, uh, if I have something like this, CH3, CHOH, CH2, it's okay. Now, what will be the point of the reaction when undergo reaction POCl3 in what in pyridine? It's okay. Remember that pyridine and H2SO4 now what THF will give us the same product, right? So you see what dehydration what reaction. Now, this carbon atom here that is having OH, two hydrogen can be removed, can remove hydrogen from here and can also what remove hydrogen from this point. Now, if I remove hydrogen from here, there is OH and one of the hydrogen. How many hydrogen you have here? Three hydrogen. If I remove one hydrogen from here, that become CH2, right? So we're going to CH2 double bond CH, then what CH what 3. That is when I remove what hydrogen from this point here. I can see the center what to remove hydrogen from this point here. You're going to be what CH3, CH3, CH, CH2. Just that. Now these two are the same. So there's no difference between this guy and this guy because the name of this guy is called propene. And the name of this guy is called what? Propene. Can you see that? So they are actually what the same. So there's no point of you writing this one again because it's what the same what product. This is that. So if I have something like this, CH3, CH2, COH, CH what 3. Now, if you undergo what reaction what H2XO4/THF, what will be the product of the reaction? Now, this carbon atom here that's carrying OH, Now you can remove hydrogen from it because connected to what this carbon and this carbon, right? So you can what remove hydrogen from here. You can also what remove hydrogen from here, right? To form double bond. So if I should remove hydrogen from here and this first carbon here, I want to have CH2, CH2, CH double bond CH3. Can you see that? That is when I remove hydrogen from here. What about if I should remove hydrogen from this carbon here? So I want to have CH3, CH, right? Then double bond CH, then what? CH3. You observe that the two of them are not the same. So here we have CH2. Sorry. So you observe that two of them are not the same, right? Now this one is called this guy is called one butene. Okay, one what butene. That is double is our coming about one. Yes, called two butene. Two what butene. Two what butene. The double is our coming about two. So two of them are what product of the reaction, but one is what is the main product. So here we have A and what here we have what and B. So which one will now be the most stable product? Now the one that remove hydrogen from here is what is the most stable product. So this is the most stable what product. This is what least stable product. So here this want to be major product, minor product. I know that you want to be careful is how do I know major product and what a minor what product? This is what I'm going to explain to you now. This is what I want to explain to you. Now, we have call the type of alkyl, the type of what carbon. Now we have call primary carbon, secondary carbon, what tertiary what carbon. So if for example here we have this guy here, hydrogen, and hydrogen. Before we close here, these are just a methyl group, a methyl what group. Like a carbon atom, they can what three what hydrogen is what is a methyl group. Now, if I have sorry, I'll write it here. Here we have arrow here, carbon, hydrogen, hydrogen. Now this is called primary what carbon, primary what carbon or alkyl, primary what alkyl group. This is that. Like the carbon is only carry what one alkyl what group, one what alkyl. From closely is only carry what one alkyl group here. Now this is what is the methyl is simplest form of carbon. Here called primary what carbon. We also have what called secondary carbon. Secondary carbon. So okay, here we have a secondary what carbon, secondary. Here we have what secondary carbon. And here we also have what tertiary. Now because of the alkyl group here we have tertiary. Tertiary what carbon. It's okay. Now here is what primary carbon. Now because of what the stability of the alkyl group, this guy is less stable. It's okay. Now the more the alkyl group, the more stable it becomes. The more that alkyl becomes. Do you get that? So primary tertiary carbon is more stable than what secondary carbon, and secondary carbon is more stable than what tertiary carbon. It's not primary is less than this, and this is the what less than this here. So it now depends on the type of carbon that I remove what the hydrogen from. So it is saying that when alkanol is undergoing reactions or dehydration reaction, the hydrogen is only removed from the most stable carbon. Do you see that? So if you check very well, now this carbon here is having a methyl group here. Do you is having what one carbon? It's okay. And this one is not having any carbon at all. Do you see that? This one is just like this guy that have what CH3. But this one here, this carbon here, just like this one that have what an alkyl group here. Do you get that? So this carbon is more stable than this carbon here. So the one that is more stable, will be where hydrogen what we remove from. That will now form what the major product. This is the what major what product. Major what product. This is called minor products. It's okay. Now the question will now be: I want to what write the But are we going to write the two of them for them and say major product and what minor product? No. Like in some question they may ask what is the major product and what a minor product. Do you get that? What is what major product and what minor product? But in some question they just say what is the point of the reaction when this undergo dehydration with what H2SO4. Now what they want to do at that point here is to give them the major product. The major product is the most important product. So you are not actually what concerned with this minor what product here, except you are being asked. Now, how do I get my major product? My major product is for when the hydrogen is removed for what more stable carbon. If you look at this carbon here, this carbon atom is attached to two carbon atoms, right? This one is for CH3 is just like a methyl group, a methyl what group. Because carbon that have what three the methyl group here. If you look at this one here, it's just like what a primary carbon, a primary what carbon. It's okay. Primary carbon is more stable than what the methyl. Just that. So that is why hydrogen is preferable to what to move from this point here. So that's why we have what two butene as what as the major what product. Do you understand? Let's look at another one so you understand very well. So if I have something like this, CH3, CH, COH, hydrogen, CH3, hydrogen, I want CH3. Can you see that? So now remember, when it will undergo reaction towards P, B, sorry, I look at the second one here, POClO3, right? In what? In pyridine. Now look at something here. Now, here we have A and here we have a B. These are the two carbon atoms here, right? Now, but if you check me very well, this one is just like a secondary carbon, right? Just like what a secondary carbon. These are just like what a secondary carbon. These are just like what a secondary carbon. Because if you check me very well, here we have this carbon add what CH3, hydrogen what CH3, right? They're directly attached to this carbon here. If you look at this carbon atom here, we have carbon here, hydrogen. So there should be two. Sorry. So here we have hydrogen, and here we have what CH3. You see that? So here we have the A, here we have A, here we have A, and here we have what B. Now if you check it very well, this one have two methyl, this one have only what one alkyl. This one is what secondary. Secondary what carbon or secondary alkyl. Now this one is called primary. Primary what carbon or the what alkyl group. You can take on the alkyl group. Now the secondary is more stable than what than primary. Can you see that? Secondary is what more stable than primary. So now the most stable product will be when you remove hydrogen from this point here. So you need to understand this here. Now, so it's very important to remove hydrogen, although they form two products, minor and what are major. But the major, the one you are actually looking for is what? When you remove hydrogen from this what more stable carbon. And secondary carbon is more stable than what primary what carbon. Do you understand? So when you remove hydrogen from this point here, let me wipe this place out. When you remove what hydrogen from this point here, you have what CH3, CH2, C hydrogen, double bond. Here we have CH3, then what CH3. Instead that OH and this hydrogen have gone out to form what H2O. This is that. But the H2O is not really what that important. You understand that you remove what OH and what hydrogen to form H2O. H2O is always formed at the end of the reaction. So here, what is the point of the reaction? So here we have 1, 2, 3, 4, 5, right? So I count about 2, I have what in methyl. So it will be 2 what methyl. 2 methyl. Now I count about 2, I have what a double bond. So it will be 2 pentene. It's okay, 2 pentene. So that is what is name of the what of the product. Now in the exam, they may ask you this question here. What will be the product of the reaction? What will be the product of the reaction when Uh, 1, 2, 3, 1, 2, 3. When 2 methyl, 1, 2, 3, 4. 4, 1, 2, 3. 3. When 2 methyl, 3 pentanol. What will be the point of the reaction when 2 methyl 3 pentanol reacts with concentrated concentrated H2SO4 in pyridine. Okay. This is just a way they can ask you the question in the what? In the exam. So when you are being asked this kind of question in the exam, now that is the 2 methyl 3 pentanol is this guy here. It reacts with what? H2SO4 in pyridine. So remember this uh, remember this phosphorus was oxide perform the same function with what? H2SO4, right? In THF. So here we have what? THF. Oh, I don't know what you say. In what? THF, right? So remember this one H2SO4 in THF perform the same function with this other one here, right? So now this is just another way you can see it in the what? In the exam. Because you may not be given instruction, they will ask you what will be the product of the reaction when 2 methyl 3 pentanol reacts with concentrated what H2SO4 in what? THF, the tertiary what from. This is called dehydration what reaction. So you have what draw the structure for them, which is this guy here. React what with what H2SO4 in what in what H2SO4 slash what TH1F. Now therefore you have to what draw the structure. Understand what the two carbon atoms the directly attached to the carbon atom that carry what OH. So the most stable carbon is where you remove your hydrogen from. So in this point here, this is the products we have. So we are done with what the second one. So let's move to the third one, oxidation of what alkanol. Oxidation of what alkanol. Now alkanol, oxidation of alkanol. Look at something here. Alkanol we have 3 types of alkanol. So just like what I've said here, this is just what methanol. Methanol. Now if I have this one here, this called primary what? Alkanol. Are you there? Then when you have something like this is called secondary. Secondary what? Alkanol. Then here we have what? Tertiary what? Tertiary what? Alkanol. Here we have tertiary. Tertiary what? Alkanol. Are you there? So in saying that, now the oxidation of the alkanol depend on the type of what alkanol it is. Do you get that? We are it depends on the what type of alkanol. So this is just like a methanol, the simplest form of what of alkanol. Now you have primary alkanol. The carbon to carry OH is only having what one alkyl group. So whenever a carbon atom that is having one alkyl group, whenever the carbon atom that carry OH is having one alkyl group, it's called primary what alkanol. Now at times it can be simple as what 1 degree, 1 degree. Now here we have secondary. That is we have 2 alkyl group. So whenever the carbon carry OH is having 2 alkyl group, now what secondary what alkanol. Do you get that? Why is it what tertiary what alkanol? And the oxidation of the alkanol, we can use 3 reagents. We have what 3 reagents. We have what 3 reagents for the reaction to occur. First, one of the reagents used in the oxidation is what PCC, which called pyridine chlorochromate. I like pyridine chlorochromate. B is what is Na2SO4 our H2SO4. It's okay. Then let's call sodium. Sorry. Here we have Na2CrO2O7. It's okay. You want H2SO4. Now this one is called sodium dichromate. Sodium dichromate. So these are what the possible what reagents here. Here we have KMNO4. It's okay. And this one is what potassium permanganate. It's okay. Potassium permanganate. The C is called Jones reagent. And Jones reagent is what chromate. Now what H plus. This that. So now these are the what possible these are the possible oxidizing agents we have. Now, but this one is called weak oxidizing agents. This is called strong. From this guy to this guy, there was strong what oxidizing what agent. There was strong oxidizing agent. So what happened when you oxidize alcohol with what pyridine? Remember, they are all strong. They are all what oxidizing agents. Do you get that? Now, but the first one is what is called weak oxidizing agent. That is not as strong as what as this one here. So I have to look at what oxidation of what primary alcohol, oxidation of what secondary alcohol, and oxidation of what tertiary what alcohol. So let's look at what the oxidation here. So here look at what oxidation of what primary alkanol. So when you oxidize primary alkanol, what will be the product? When you oxidize primary alkanol, what will be the product of the reaction? Now, check that. Oxidation of primary alkanol will produce aldehyde. Oxidation of what primary alkanol using weak oxidizing agents such as what PCC, pyridine chlorochromate, will produce aldehyde as a product. Then further oxidation will produce what? Will produce a carboxylic what acid. So you say that when you use a weak oxidizing agent to what oxidize primary alcohol, remember that primary alcohol is like this. C hydrogen, any alkyl, hydrogen, then what OH. This that. So a good example is what this can also be written a lot. ReL CH2OH. It's called primary what alkanol. A good example is what CH2OH. It's okay. So this is called one propyl. So one propanol. One what? One propanol. One what propanol. So when one propanol undergo oxidation with what weak oxidizing agent here, PCC, pyridine chlorochromate here, pyridine chlorochromate. This one is a weak oxidizing what agent. Now a weak oxidizing agent will produce an alcohol. So one thing I want to understand is that now when we talk about oxidation, oxidation means what? Removal of what hydrogen, removal of what hydrogen, that's removing what hydrogen, addition of oxygen. So now it is the carbon atom that is having what OH. We convert it to what to an aldehyde functional group. So here we have CH3, CH2, C. It occurs at this point here. So you have removed what hydrogen, now we form an aldehyde what functional group. This is called propanol. This is that. Now, so whenever I want a primary alcohol is oxidized with what weak oxidizing agent, with weak oxidizing agent, it must be weak. Therefore, you have to convert to what to an aldehyde functional. Do that. Then further oxidation will now produce what a carboxylic acid functional. Here we have CH3, CH2, C. So here we are going to be propanoic what acid. Propanoic what acid. So this is what is the product of what of the reaction. Do you get that? So whenever you are using a weak oxidizing agent to oxidize a primary alcohol, the reaction will occur twice. So therefore, it must convert to what aldehyde. then further reaction that produces what to carbonate what acid. Do you get that? So if I should give you some for you to try, if I give you some for you to try, here we have CH3, CH2, 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 OH, PCC, A, then here we have what? PCC, B. So they ask what is what? What is A and what is B? Just that. So it's very easy here. Therefore, PCC we oxidize this one to what to an aldehyde functional. This is that. So the product, let me just write it down. The product here is going to be CH3, CH2, CH2, C. This that. So you have oxidized what this point and this camera to CH2OH now to an aldehyde what functional what group. So you know this guy is what is one butanol, one what butanol, one butanol. So when one butanol undergo on reaction with PCC within chlorochromate. Now you're going to form butanol. You're going to form what butanol. Then further oxidation with what PCC we produce what a carboxylic acid. We produce what a carboxylic acid. So here we have CH. Remember I tell you that you know butanol, right? So further oxidation that produces what? That produces what? Butanoic acid. Butanoic acid as what? As a product. Do you understand? When you oxidize formal alcohol with strong oxidizing agents, you're going to produce what? A carbonic acid straight. So for example, here we have CH3, CH2, CH2OH. Now when you pick any of the strong oxidizing agents like what? KNNO4, which one is a strong oxidizing agent? Now you're going to oxidize from what straight to carbonic acid. It means that now because the PCC is a weak oxidizing agent, that's why I convert to what to aldehyde. For aldehyde, not produce what to carbonic acid. Now, but when you're using any of the strong oxidizing agents, either what sodium dichromate or potassium permanganate or what Jones reagents, now you're going to convert the alcohol to what to carbonic acid straight. So let me say that when you remove P sample, really what and KMNO4, that will produce what CH3, CH2, C. Do you see that? Same here, we have something like this. CH2OH. Now we oxidize it with what? NaC and Na2. Na2CrO2O7. So now what H plus. When you convert it to what to carbonic acid. It's okay. So here we have this one is going to be what benzoic acid. Benzoic what acid. Then here going to be what propanoic what acid. And the propanoic what acid. So that is it. So oxidation of what primary alcohol with weak oxidizing agent will produce aldehyde. The further oxidation now produce what a ketone. So a carbonic acid. But when you oxidize it with strong oxidizing agents, like either what KMNO4 or what this other one here, now you're going to produce carbonic acid straight. So you need to differentiate. You need to understand when you're oxidizing what primary alcohol. When you're oxidizing, you need to understand when you're oxidizing primary alcohol with weak oxidizing agent and what strong what oxidizing what agent. So the next thing here is what oxidation of what secondary alcohol. Oxidation of what secondary alkanol. So when you're oxidizing secondary alkanol, what will be the product of the what reaction? When you're oxidizing for secondary alkanol, what will be the product of the reaction? Like remember when I told you, secondary alkanol is what is the what is when you're having a carbon atom carry OH with what two alkyl group. It's okay. A good example is what CH3, CH, OH, CH3 here. This is called secondary alkanol because the carbon carry OH that got two alkyl group. This is that. So now, whenever you oxidize secondary alkanol with any of the oxidizing agents, it can either be PCC or anyone. The product is going to be alkanol. Do you get that? Going to be what alkanol, which is called ketones. So when I have CH3, it's okay. So here we call propanol. So oxidation of what secondary alcohol with any of the oxidizing agents, we will produce what alkanol, which is called ketones. So you have to understand oxidation of secondary alcohol will always produce a ketone as a product. Same thing here we have CH3, CH3, C. So can use your Na2CR2O7. It's okay. What will be the product of the reaction? This one will change what to a ketone. So here we have CH3, CH2, C. So then is now the product. So we're going to do what? Butanol. That is what is the product of the reaction. This is that. So oxidation of secondary alcohol will only produce a ketone, no matter what the oxidizing agent what you make use of. The next one is what? Oxidation of tertiary alcohol. Oxidation of what? Tertiary what? Alcohol. Oxidation of what? Tertiary what? Alcohol. Oxidation of tertiary. Tertiary what? Alkanol. Oxidation of tertiary what? Alkanol. So what happens when you oxidize tertiary alkanol? See, here we call tertiary what? Alkanol. See, tertiary alkanol do not undergo oxidation. So oxidation of what? Tertiary alkanol will produce no reaction. There will be what? No what? Reaction. So it means that you cannot oxidize tertiary what? Alkanol. So you have to understand this here. For example, here we have CH3, 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 OH. This is called tertiary what? Alkanol. Tertiary what? Alkanol. So if you want to use the strongest oxidizing agents, we would avoid how you oxidize what with strong oxidizing agents. It cannot produce what any what results. There is no what result. Do you get that? So no reaction. No what reaction. It's okay. So oxidation of what? Oxidation of what? Tertiary alcohol with any of the oxidizing agents, no result what we form. Do you get that? So we have done what oxidation of what? Primary, secondary, and tertiary. The last reaction of that alkanol is what? Esterification. About esterification is very easy here. It's the reaction of what? Of carbonic acid and alcohol in the presence what? Of acid catalyst to produce esters as a product. I'll go back again. Esterification is the reaction between carbonic acid, that is when carbonic acid react with alkanol. The product we call what? The product is going to be esters. And the reaction is now esterification. So here we have a carbonic acid. This is called carbonic acid. Now when you react with any of the word alkanol at all, either primary, secondary, or tertiary, now it must be is a reversible reaction. It must be other acid catalyst here. So what happen here? This OH will go with this other one here. You see that? This OH will go with this other one here. So here we have R here, C, here we have O what? R, that is it. This is that. So inside that is one plus what? H2O. It's that OH and this hydrogen. Now that is when you react carbonic acid and alkanol. Now you are only going to produce water as a what? As a product. So it is saying that when you remove hydrogen from here, you have what? I will here C. Right? Then when you remove OH from here, you have what? So this is what we combine together here. So you call ester. This is that esters. So if for example here we have CH3, C, here we have what? Ethanoic acid. Ethanoic acid. Now when we react what with methanol, methanol. Is okay. H plus. What will be the product of the reaction? So OH will go with this one here to form H2. Just that. So what I have left is what CH3, COCHO3. Just that. So this is now what the point of the reaction. So I have done a complete video on notation of what of esters, so you can check it out at the description below. But I'm still going to teach you here. So is CH3, CH2, CH2, C plus what? CH3, CH2, OH to produce what? Now reactive in what? So what will be the product of this reaction here? It's okay. Here we have what 1, 2, 3, 4. Here we have butanoic acid, butanoic what? Acid. And here we have what? Ethanol. Here we have what? Ethanol. Ethanol. So what happened here? OH, then what? Hydrogen, right? So here we have. So when you remove from here, what will happen here? Here we have CH3, CH2, CH2, C. It's okay. It's okay. So what I want to do here, now the mistake so many people do here, they will write like this and put CH3, CH2, CH2, C. I have seen many students writing this one in the writing this one. This is not the product. Do you get this is that? Remember the OH is being removed from what? Carbon with what? Two hydrogen, right? So that is how to what come like this and form CH2, CH3. So this is what is the wrong one, this is what is the what right one. Do you understand? So what will be the product here? Here we have what? Ethyl. Here we have ethyl. Here we have what? The alkanoids. So going to be 1, 2, 3, 4. Going to be butanoids. Going to be butanoids. So going to be ethyl butanoids. It's okay. Ethyl butanoids. Now, if you are still confused on what on the what nomenclature of what of the ester, I've done a complete video on what nomenclature of what ester. So you can check what my YouTube channel. You see nomenclature of what of the esters. You can go ahead and watch that video. I believe it's going to be of help to you. So that is what that is the reaction of what of the alkanol. If this video is helpful, leave at the comment section. This video is helpful and gain a lot of value from it. So the reduction reaction aspect of what alkanal and what alkanol. Now, this is one major reaction that the carbonyl functional normally what undergoes. So now this you can reduce ketone or aldehyde into what alkanes and what alkanol. Do you get that? Depending on the reagent what you are using. So to reduce the carbonyl, when I talk about the carbonyl, I'm talking about ketone and what aldehyde. If I want to reduce the carbonyl into what alkanes, I can achieve that using two major what reagents. One, I can use what hydrazine in pair what strong what base, strong base, and this one is called Wolff-Fishler what reduction reaction. Do you get that? So in the Wolff-Fishler reduction reaction, you need two things here: the hydrazine and what strong base. Then you also need, then you can also reduce it to water alkane using this zinc mercury in pair of a strong acid catalyst. Now this is called Claise-Mason reduction reaction. So these two will achieve similar what results. So if for example here we have a carbonyl here, this called what an aldehyde functional aldehyde, and this called what ketone. This called what ketones. You understand? So now when you reduce it with what any of these reagents here, H2, where what strong what of a strong what base. Now there must be a pair of a strong base. Do you get that? Now the same here, I can use the zinc Ag plus plus. Then here I have what H plus. Do you get that? So this will also reduce for here. The goal here is to what reduce to what corresponding what alkanes. So when you use one in the reduction here, this oxidation change was CH2. So I have some like arrow here, CH2 hydrogen. It means that it have reduced this one to what? To the what? Normal carbon. You get no functional group again be involved. The same thing here, arrow here, CH2H. Now this will also be what? Arrow CH3. Arrow, arrow, sorry, here we have arrow here, sorry. Here we have arrow here, here we also have what? Arrow here, CH2. Yes. So this is what is the reaction. But understand that the reduction will occur in the what functional what group. So now let's take a good example here. So if you are oxidizing, okay, let's check this one here. CH3, CH2, CH2, and you are reducing this one here using what? Now let's use, it's okay. It can be what? HCl. So the reduction will take place here. This one will reduce it to what? Completely what? Carbon, no functional group again. So it's going to be CH3, CH2, CH2. Now 1, 2, 3, 1, 2, 3. Then here we have what? CH3. So you can see that it has reduced it completely to what? To alkanes. Now this one here, the name is what? 1, 2, 3, 1, 2, 3, 4. It's what? Butana. But here's what? It's butane. Now, what you want to put in your mind here is that you must actually what give the product or the name of the product of the name of the what of the product or the name of the reaction is very important. You must give out the name of the what of the product. Now, the same here, if I should use what NH2 NH2 KO, this is called hydrazine. Hydrazine is okay. In the word of a what strong base. Now it's going to reduce one here too towards CH2. So here we have CH3, CH2, 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 there was CH3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here we have pentane. Pentane. Here it's called 2-pentanol. You get this that is what that is the point of the reaction. So that is the point of what of the reaction. You have to be taking of this. Now let me show you the ways you'll be asked in the exam. Now this is what the way and pattern you see it in the exam. Give the product of the reaction when 2-phenyl ethanol is reduced by hydrazine in what in KOH. Now it's going to talk about the reduction reaction to the alkanes. So the first one to do here is what give the structure, the complete structure of this guy. You want to talk about ethanol, CH3, C. This is called ethanol. Now, but the phenol is our account number 2. So here I have 2. Can you see that? So here it's called phenyl ethanol. So when you reduce it, here we have NH2, NH2/KOH. What will be the point of the reaction? Now, this will be reduced completely to what? To alkanes. Do you see that? So here I have CH2, right? They have CH3. This is that. You can see that this one here has completely be reduced to this here. Now, the next one to this one give the complete name of this guy. So the name is going to be ethyl benzene. Ethyl what? Benzene. So you have to work. That is why you need to master the nomenclature of the organic compound. You get it's very very important. And I've done tons of videos because of the nomenclature of what of the organic compound. You can check out the playlist of what of the nomenclature and you see a complete video on that. So we are done with this one here. Let's move to this number 2, reduction of carbon into corresponding alkanol. So for you to reduce carbonyl into corresponding alkanol, you need any of these reagents here. You need your sodium borohydride in water. I also need what lithium aluminum hydride in water. there's still another reagent you also need is what? H2 slash what? Ni. Do you get that? This can also be what? This can also be a good reagent for you to what? Reduce carbonyl into what corresponding alkanol. So you can use any of these reagents to achieve that result. So if, for example, here I have it's okay when you reduce it using what? Sodium borohydride in what? In H2O. Do you see that? Now, this one here will be what? Reduced to what? To alkanol. Do you get that? Now, because when we talk about reduction reaction, it means what? Addition of what? Of hydrogen. Do you see that? So this one here will be going to what? To alkanol. So here, this is what we want to get as the product. OH H2. Can you see that? So you can see that this carbon here has been reduced to what? To alcohol. It's very important. The same thing here, if I have something like this, I can use H2 slash P N R. Now you still get the similar what result. You're still going to have. Now, if I still use lithium aluminum hydride in water, I will still get the same result. Do you see that? So reduction of carbonyl into corresponding alcohol. This is what you want to make use of. You can use any of this what reagents here. So the next thing is that what will be the name of this product here? Now here I have the functional group of what alkanol. This can now be a source strength. So it's going to be 1, 2, 3, 3 phenyl 3 phenyl. Now, the oil is like carbon number one. How many carbon do you have here? 1, 2, 3. 1, 10, 1 propanol. This that. So it's going to be 3 phenyl because here it's going to be like carbon 1, carbon 2, and carbon 3. Phenyl is our carbon number 3, right? So it's going to be 3 phenyl 1 propanol. The same thing with this one here. So that is why you need to what master the nomenclature of the organic compound. Is very, very what important. So that is it for this video. That is all for the reduction aspect of what of alkanol and alkanol. Please watch out for this type of what reaction here because you see them in the exam. If this video is helpful, please give it a thumbs up, subscribe to the channel if you have not done that, and leave your comment at the comment section. Please, I value those who comment on the video, not those who engage in the video are more important to me than those people who just watch and just go like that because it made the community what active. If you have any question you want to ask, you can leave at the comment section. I will respond to that question. You can also share this video to your friends and classmates who are also learning this course and want to write the exam. Do you wish you success in your exam? So that is for this video.